Hey guys, me again. So I'm going to continue on the Algebra 2 Unit 3 review, but now I'm going to talk specifically about the calculator section. On the calculator section, you still need to show your work, even though you will be able to have your graphing calculator. Okay? So, all of this is like listed right here of what you need to know, but I also cover it within the next pages of your review. So I'm just going to go straight into the problems, but feel free to read this and kind of like check off if you know that, highlight it if you don't, so you know you need to go back and study. So let's first look at number 6. It says write a fourth degree polynomial in standard form with the following zeros. Okay, now remember we learned this is like when we say that n is 4. That's how our problems have looked like. That's the fourth degree. But remember, we learned that the degree equals the number of zeros. Okay? So if I look at my zeros, those are your x values, I have 1, 2, 3, but I'm supposed to have 4. So you need to look here and be like, oh, I remember. My teacher told me, because this is a complex number, they come in conjugate pairs. If I have 4i, I also automatically have negative 4i, even if it's not listed, right? So now I have 1, 2, 3, 4 zeros, which makes sense because I need a fourth degree polynomial. Okay? So now let's write these each as a factor. X equals 1, that would be x minus 1. Remember, you're just going to move it to the same side as x. This would be x plus 1, because I'm going to add 1 to both sides. This would be x minus 4i, because I'm going to subtract it, and this would be x plus 4i, because I need to add it. All right, now if I were you, I would kind of like split this up, focus on this side, foiling that, and then focus on this side, foiling that. If you have an imaginary number, make sure you guys do take care of the i's together, because stuff will cancel out and it turns out a lot nicer. All right, so let's FOIL over here. So I get x squared, x times 1 is 1x, I get negative x times negative 1, and those cancel, so I'm left with x squared minus 1 right here. And then on this side, I get x squared plus 4ix minus 4ix minus 4 times 4 is 16. I times I is I squared. Now, do we remember what I squared equals? Negative 1. Anytime you have an I squared, replace that with a negative 1 right there. So this, notice 4ix minus 4ix cancels, so I'm left with x squared. Two negatives make a positive, so that's positive 16. All right, so now I'm down to this, and I'm going to FOIL those two out together, okay? I'm actually going to erase this a little bit right here so I can FOIL that. Okay, so I get x squared times x squared. I'm going to write that over here. Is x to the fourth. X squared times 16 is 16x squared. Negative 1 times x squared is negative 1x squared. Negative 1 times 16 is negative 16. Combine any like terms. We got these two. So I get x to the fourth plus 15x squared minus 16. And notice my degree is 4, and that's what I was supposed to have. So yay! That's the way to check yourself. Okay, guys? All right, let's keep going. Factoring, everybody's favorite. So we're going to fill out this factoring chart below. I'm just basically going to go over the formulas first. Whenever you have a difference of two squares, well, okay, let me start over. Factoring, always look for a GCF, right? Then look at the number of terms that you have. If you have 2 terms, you have 3 options. If you have 3 terms, remember that's a trinomial, you just guess and check. 4 terms, you're going to factor by grouping. So if you have 2 terms and you can take the square root of both of them and there's a minus sign, you have a difference of squares. If that's plus, remember it's not factorable. So anyways, you take the square root of a squared, and that goes in the first spot. Then you take the square root of b, that goes here, and then one's plus and one's minus. That's always the layout, okay? Difference of cubes. You should be, or you will have to be able to take the cube root of both, and it has to have a minus sign. Now, remember, the minus sign just tells you the formula you're using, okay? Don't think of it as like a negative number. So anyways, we get a and b, a squared, a times b, b squared. And that's actually the same layout for the sum of cubes as well. And then remember on these two, SOAP. Same, opposite, always positive, okay? So because this is a minus sign, same, opposite minus is plus, always positive. Because this is a sum of cubes, same, opposite positive is negative, always positive. So those are your formulas. And to get A and B, remember you're just going to take the cube root of A and the cube root of B and plug them in that formula, okay? All right, guess if you have 3 terms, remember that's just guess and check. That's when you set up your 2 sets of parentheses. And then factor by grouping. If you have 4 terms, remember you're going to group the first 2 and last 2 terms. Then you're going to find the GCF of each. Take that out. Then whatever is the same in parentheses, is one factor, and the other factor is your GCFs combined. I have a factoring by grouping problem later that we'll get into, okay? So those are just the steps that were in your notes, just kind of shorthanded, okay? All right, so let's go to the next page of the review. All right, so, oh, sorry guys. Let's factor these following functions below. So remember, if you are referring to your factoring chart, look for the GCF first. Notice I can divide both 32 and 4 by 4. 32 divided by 4 is 8. And I have x to the third minus 4 divided by 4 is 1. All right, notice that I can take the cube root of these. Or, I'm sorry, I have 2 terms. So I looked, is this a difference of cubes, sum of cubes, or difference of squares? These are cube roots because I have x to the third right here. So it's going to be sum or difference of cubes, and it's difference of cubes because I have this minus sign right here. Sorry, I was just rewriting that 3. All right, so the cube root of 8 is 2, and if you didn't know that, if you hit math number 4, you can type in 8. Okay, you cannot type in a variable into your calculator. So my a value is 2, and x to the third is just x. My b value, the cube root of 1, is just 1. Again, you can type that in your calculator if you need to. So now I just plug it into my difference of cubes formula. Well, first off, there's my GCF. Then I have a and b, and because it's difference, I do same sign as what I started with, parentheses, a squared. So when I do 2x squared, 2 squared is 4, x squared is just x squared. So same, opposite, a times b, that gives me 2x, always positive. So plus, and then 1 squared is just 1. And I'm done. Now remember, you guys cannot factor that quadratic further, so you can just stop there. Okay, don't forget to write down your GCF. All right, letter B. Let's see here. It looks like we have no GCF. We have 3 terms, so I'm just going to go straight into guess and check. Well, x squared times x squared will give me x to the 4th. That's my only option. Factors of 24 that add or subtract to get 2. Let's see here. 6 and 4. All right. This gives me 6x squared. This gives me 4x squared. If I do 6 minus 4, I get positive 2. So plus 6 minus 4. 6 times negative 4 is negative 24. Notice that I cannot factor this part further because I cannot take the cube root of 6, or I'm sorry, the square root of 6, and that's not a minus sign. But over here, I can take the square root of both these, and that is minus sign. So this is a difference of squares. Okay, so I have x squared plus 6. What's the square root of x squared? X. Square root of 4 is 2. One's plus and one's minus. So keep going as far as you can, okay? Letter C. No GCF. I have 1, 2, 3, 4 terms, so I'm going to factor by grouping. Group the first 2, group the last 2. Let's find the GCF of each. GCF, the first group, is x squared, so I'm left with x minus 3. GCF of group 2 is 7. I'm left with x minus 3. Oh, notice, yay! Remember, these have to be the same. If they're not, you did something wrong. So that's one of my factors. My other factor are my GCFs combined. So x squared, and that's a positive 7. That's why I took out. So this is x squared plus 7. Look to see if you can factor any of those further. You cannot, so you're done. Okay, so that's a little quick factoring review. All right, number 9. How do you find the zeros of a polynomial function by factoring? So if I factor, how would I find these zeros of these problems? Well, you would just take each of those factors and set them equal to zeros. So set the factors equal to 0 and solve for x. Okay? That's kind of like what we did here on the non-calculator section. See how we took each factor and set them equal to 0 and we solve for x? That's what that means. Okay? All right, it says, how can you determine how many zeros a polynomial function will have before solving for the zeros? So remember, the degree of the polynomial equals the number of zeros. Okay, so like up on letter A, I have a degree of 3, so if I were to solve for x, I would get 3 x values, or 3 zeros. Okay, over here, I have a degree of 4, so I would get 4 answers. And over here, I have a degree of 3, and I would get 3 answers. Okay, that's what that kind of means there. So this went with that. This goes with that guy. All right, number 10. This is like a little review over the operations in polynomials. It says, perform the indicated operation, use synthetic division for the division problem. So, let's see. This is addition, so I'm just going to combine like terms. So, let's see here. 4x squared, negative 12 plus 3, negative 9, right? 9 minus 11, negative 2. And I'm done. Just double checking my math to make sure I'm not doing anything silly. Okay. Oh, wait. Oh, 9 minus 11. Yeah, I did that right. Okay. Letter B. This is multiplication, so you're going to either distribute or use the box method, okay? I do not care what you guys decide to do. Just for, like, neatness, I'm going to use the box method here. All right, and remember the box method, you're just going to multiply the terms together to fill in the box. So 3x to the third times x is 3x to the fourth. This would be minus 8x to the third. I'm just going to multiply all these by x, essentially, right here. So 2x squared minus 7x. And then I'm going to take all these terms and multiply them by 2. So 6x to the third minus 16x squared, 4x minus 14. And then I'm going to combine my like terms, and remember the degrees match up sideways. So 3x to the fourth, 6 minus 8 is negative 2, negative 16 plus 2 is negative 14, 4 minus 7 is negative 3x minus 14. I just like how nice and neat the box method can be. But yeah, you can just use the distributive property there if you would like. I'm okay with that too. All right, letter C. This is subtraction. Don't forget you want to distribute that negative first. Do this first, and then second, you're going to combine your like terms. Okay, so I get x squared minus 6x plus 5 minus 2x squared minus x minus 1. All these signs just become, you just flip it, flip the sign. Okay. All right, so I have x squared minus 2x squared. That's a 1. So 1 minus 2 is negative 1. Negative 6 minus 1 is negative 7. 5 minus 1 is 4. You're done. All right, and letter D, this is the division. Okay, remember you're using synthetic division. So this has to be in the form x minus h, okay? So x minus, this would be -3. That's another way to write that. So my h value is -3. And then I remember I put the coefficients of what I'm dividing up here. Fill in a 0 for any missing terms. So if you have like a missing degree, that's when you're going to plug in a 0. I start at 3, 2, 1, 0, so I'm good. I don't have to fill in any missing terms. So I have 2, -4, -15, and 4. Bring down the first term. Okay. Multiply, add, multiply, add. So -3 times 2 is -6. And I'm going to add these. So you multiply here, and you add here. Let's see, that's -10. -10 times -3 is 30. Minus 15 is 15. -45. -41. Okay? And because I started with x to the third, my answer will start with 1 degree less than that. So x squared, x to the first, x to the 0, your remainder. So my answer is 2x squared minus 10x plus 15 minus 41 over x plus 3. Okay? All right, number 11. A polynomial is divided by x minus 9 and the remainder is 2. So to kind of draw you a picture there, that means we put 9 in the box, right? I'm dividing by that, and the remainder was 2. So over here, when I do my synthetic division, 2 is my final answer as my remainder. What does this tell you about x equals 9? Sorry, I deleted that out. If that's still on your paper, it says the root, but delete that. So what's this tell you about x equals 9? It's not a factor, right? But there is a coordinate point of 9, 2 on the graph. Okay. Remember, in order for this to be a factor, the remainder has to equal 0. Okay. So just be careful of that. All right. That was just that question was just to remind you of that. All right. Number 12, it says graphically, where do relative max and mins occur compared to the zeros of a polynomial function? So where are our maximums and where are our minimums? They are in between the zeros. So those lie in between the zeros.